Yesterday, I gave you guys a formula, and it was x minus mu over sigma. And I mentioned that the mu, right? I'm using some Greek letters. The mu, it is average. So x minus the average. If my number is above the average, I'm going to have a positive number. If my x, the number I'm looking for, is below the average, I'm going to get a negative value. But the top of my fraction, x minus mu, or x minus average, is just for me to know what's the difference from my average. My bottom, I just call it right now, is sigma. That's a Greek letter, sigma. And that is going to stand for standard deviation. That's going to give me my C-score. We talked about yesterday how to find out the C-score and how to use the C-score. So let's take a look. A patient recently diagnosed with Alzheimer's disease takes a cognitive abilities test and scores 59. So this person took a test and his score was 59. The mean on this test is 52 and the standard deviation is 5. What is the patient's percentile? First of all, let me find out my C-score. The person score of 59. The average, the mean on this case is 52. And I'm going to divide this. The standard deviation here, it is 5. So let me get my calculator out. I'm just going to go 59 minus 52. I find out that the difference on the top is 7. It's a positive since the guy scored higher than the average. And I'm going to divide this by 5. So my C-score in this case is 1.4. That's my C-score. I gave you guys a table and I said 1.4. My first case, my list on the left, that tells me up to my first decimal place. So this list right here tells me up to my first decimal place. So 1.4 is here. My second decimal place was a 0, right? So my second decimal place is here. So 1.40 or 1.4 happens to be 0.4192. So 0.4192. Let me write that number, 0.4192. Okay, so now here it says what's the percentage? I'm just going to come and say 0.50 plus I'm going to add, since my C-scored, I'm going to highlight my C-scored. Since my C-score was positive, I'm going to add. If my C-score would have been negative, I would have subtracted. So my C-score was positive, so I'm going to add 0.4192. So let's see, 0.5 plus 0.4192. Now here I'm asking for the patient's percentile. That's percent. My decimal, 0.9192, my answer. I'm going to round it. I'm going to move my decimal 2 places to the right. So my percentile will be 91.92%. So what does this mean? If 0 was the lowest scored, 100 was the highest scored, this guy is at 91.92. So once again, if 0 was the lowest scored, 100 was the highest scored, he is 91.92. He scored pretty good. Now let's take a look at question number 14. A patient recently diagnosed with Alzheimer's disease takes a cognitive abilities test and scores a 50. The mean on this test is 52. So remember my formula, x minus mu. I'm just going to go 50 minus 52. all over. Standard deviation is 5. This is going to give me my C-score. So let me grab my calculator for that. 50 minus 52, we get a negative 2 divided by 5. It gives me my C-score is negative 0.4. Let me use my chart. I want to know what's 0.4. What information does that give me? So 0.4 is right here. My second decimal place was 0. 0.4 is the same thing as 0.40. So 0.4 gives me 0.1554. 0.1554. Remember, I got that from this table. Okay, so how am I going to find my percentage? I'm going to go 50%, which is the average, minus, I'm going to subtract this time because my C-score is negative. So minus 0.1554. 1554. I have percentage. Don't forget to move the decimal twice to the right. I have 34.46%. Once again, what does this mean? If 0% is the lowest scored, 100% is the highest scored, this guy scored at 34.46. It is below the average, right? Average is 50%. Like 0.50 will be your right in the middle, your average. Now this guy is below average, but yeah, he scored 50. The average is 52. He scored lower. Now let's take a look at this case. A fifth grader takes a standardized achievement test. The mean is 125. Remember my formula, x minus mu, so x minus the mean over sigma, which is we use that Greek letter for standard deviation. So the mean is 125, the standard deviation is 15, and this guy scores 112. What is the child's percentile? I'm just gonna go, he scored 112 minus 125, which is the mean. And I'm gonna divide that by 15, which is the standard deviation. And once again, that's gonna give me my C-score. As a matter of fact, I even go here. Z equals that. So I'm just gonna go 112 minus 125 divided by 15. I'm gonna run it to 2 decimal places. So it gives me negative 0.87. Once you guys take a math analysis, they're gonna say, well, this is roughly between 0.86, 0.87. So roughly like right in the middle. Like I said, that's when we guys gonna be taking the stats class. But we're in algebra 2 class right now. So in our case, let's run it to 2 decimal places. So 0.87. So let me get my C scored, get my table. Remember my C score was 0.87. So 0.8, that is right here. Remember my table on the left, that gives me up to my first decimal place. So 0.8. My second decimal place, I see it up here. Here's my 7. So 0.87 is there. 0.87 is 0.3078. So let me remember that. 0.3078. So I'm going to say, well, what is this child's percentile? I'm just going to say 0.50, 50%, minus, since my C-score is negative, I subtract. So minus 0.3078. 0.5 minus 0.3078. 30. Let me see, 0.5 minus 0.3078. That gives me 0.1922. Percentage-wise, I'm going to write that as 19 point. I'm going to move my decimal twice to the right. 19.22%. Yeah, not the best score we can see, right? Not pretty low. 19.22% is pretty low. Remember what does that mean? 0% is the lowest, 100% is the highest. This kid is 19.22. It's pretty low. All right, let's take a look at number 16. Fifth grader takes a standardized achievement test. The mean is 125. The standard deviation is 15. He scores 130. I'm just going to go 133 minus 125 divided by 15. That's going to give me my C score. So 133 minus 125. Divide this by 15. It gives me 0.53. I'm going to use my chart. 0.53. So 0.5 up to my first decimal place is right here. 0.5. My second decimal place is here. So 0.53 is 0.2019. So 0.2019. Double check. Yep. Okay, so what does this do? I'm just going to say 0.5 plus 0.2019. And it gives me 70.19%. Now, Pat and Chris, they both took a test, spatial abilities test. The mean is 80, the standard deviation is 8. Now, keep in mind, now I have two people, Pat and Chris. Now, Pat scores a 70%. And Chris scored a 90%. What proportion? So I'm asking for proportion. I want this as a decimal. What proportion of individuals will score between Pat and Chris? Let me find out for Pat and let me find out for Chris. Let me find out both informations. Pat and Chris. So Pat scores 70. So for my C score for Pat, I'm just going to go 70 minus 80, since the mean is 80. And I'm going to divide this by 8. That's going to give me the C score for Pat. Now for Chris, I'm just going to say Chris scored 90. So I'm just going to go 90 minus 80 divided by 8. It's going to give me the C score for Chris. All right, 70 minus 80. That's a negative 10 divided by 8. So for Pat, I'm going to have a negative 1.25. Let me find out my C score for Chris. 90 minus 80 divided by 8. I have a positive 1.25. Okay, yeah, they're basically 10 points from the mean. So now let me use my data, my table here. I'm going to look for 1.25. So 1.2 is here. The 5 is here. 1.25 is 0.3944. 0.3944, and I use the same on both. Why? Because they have the same C-score. I know one is positive, one is negative, but they have 1.25, both of them. So notice I just look for 1.25. Okay, I'm using the same value. So for Pat, I'm just going to go 0.5 minus 0.3944. For Pat, the percentile that I get is 0.1056. For Chris, I'm just going to go 0.5 plus, I'm adding since the C-score is positive, plus 0.3944. So Chris, the percentile that Chris has is 0. Or 0.8944. Now here it says what proportion, notice I'm leaving it as decimals, what proportion of individuals will score between Pat and Chris. What I'm going to do, I'm going to subtract these numbers. Starting from Chris because he's the higher value, so 0.8944 minus 0.1056, and I'm going to say, I'm going to leave it as a decimal. It's going to be 0.7888. So about 78.88% of the people that take this test will be in between Pat and Chris. Number 18. So Pat and Chris both took a spatial abilities test. The mean is 80. The standard deviation is 8. So Pat scores 82. So I'm going to have to figure out Pat. Pat, the z-score for Pat is going to be 82 minus 80 divided by 8. I have to figure out Chris. Chris score, the z-score for Chris is going to be 95 minus 80 divided by 8. Okay, let me figure it out. So 82 minus 80 divided by 8. So for Pat, I have 0.25. For Chris, 95 minus 80, that gives me 15. Divided by 8, I have 1.88. Once again, in my case here, I'm rounding my z-score to 2 decimal places. I'm going to call this 1.88. All right, so there are different values. I'm going to have to use my table twice. My first one was 0.25. So 0.2 is here. My 5 is here. So 0.25 is 0.0987. 0.0987. All right, 0.25, yeah. Now my other z-score was 1.88. All right, so 1.8 is right here. My second decimal place is here. So 1.88 is 0.4699. Let me double check. Yeah, 0.4699. Okay, so I found the percentiles of each. Now the question is, what proportion of individuals, well, actually, I found the proportion of each because I left it as a decimal. What proportion of individuals will score between Pat and Chris? So let me go 0.4699 minus 0.0987, and it gives me 0.3712. Once again, since I'm asking for a proportion, don't move the decimal place. Just leave it as it is. If I had asked you for percentage, I would expect 37.12%. All right, let's take a look at examples 19 and 20. So the Welcher Adult Intelligence Test Scale is composed of a number of subtests. On one subtest, the raw scores have a mean of 36 and a standard deviation of 6. Here's my mu. Here's my sigma. Remember, our formula is x minus mu over sigma. Assuming these raw scores form a normal distribution, what proportion? So leave it as a decimal. Don't move the decimal place. Of raw scores are between 32 and 40. So I have to find out both scores, 32 and 40. So I'm just going to do for 32, I'm just going to go for the C scored. I'm going to do 32 minus 35 divided by 6. Remember my 35, that's my mu. That's the average or the mean. My 6 is my standard deviation. So that's going to give me my C score for that. But I also have to find out my other C score. It's going to be 40 minus 35 over 6. Let me find out both C scores. So 32 minus 35 is negative 3. Divided by 6, I have a negative 0.5. Now let's take a look at the other one. 40 minus 35 is 5. Divided by 6, I have 0.83. Let me get my table. All right, my first number was negative 0.5. So 0.5 is here. My second decimal place was a 0. So that gives me 0.1915. That's my percentile, my proportion for the first value. Let's find out my proportion for the second value. My 0.83. 0.8 is here. My 3 is here. So 0.83 is 0.2967. Again, I get that from this table. So, okay. So what proportion of the raw scores are going to be between those two values? I'm going to go 0.2967 minus 0.1915. And I have 0.1052. All right, about 10.52% of the population are going to score between 32 and 40. Incorrect, actually. Let me go back a little. Forgot to do one thing. 0.1915. Yeah, I didn't quite find a percentile. My bad. Let's see. 2967. I forgot to do one more step. Here I have 0.5 minus 1915. I didn't find my percentile. So 0.5 minus. I had to go minus since my C-score was negative. So 0.5 minus 0.1915. Now, actually, the percentile of 32 is 0.6915. Now, my other case, I have to go 0.5 plus 0.2967. Not that I made a mistake. I was just checking if you guys were awake. So that gives me 0.7967. Now let me subtract those two values. And it gives me 0.1052. So it's about 10.52% of people are going to score between these two values. Now here, what are we going to do here? Let's see. We have the same test, the subtest. I'm looking at question number 20. The raw scores have a mean of 35, and the standard deviation is 6. Assume these raw scores form a normal distribution. What proportion of raw scores are between 37 and 42? So if you score 37, let me find out the C scored. And if you score 42, let me find out the C scored. So for 37, I'm going to go 37 minus 35 over 6. That's going to give me the C scored. For 42, I have to go 42 minus 35 over 6. That's going to give me the other C scored. So let's see. 37 minus 35 divided by 6. It gives me 0.33. Now the other number, 42 minus 35 divided by 6, gives me 1.17. Let me use my table here. All right, the first number was 0.33. So the 0.3, and then the second 3 is here. So 0.33 is 0.1293. All right, 0.33 gave me 0.1293. Just double check. Okay. Now the other one, it's 1.17. So 1.1 is here because once again, this row gives me up to the first decimal place. My 7 is here. So 1.17 is 0.3790. Let me double check. Yeah, 0.3790. Okay, so let me find the percentiles of each. I'm just going to go 0.5 plus 0.1293. And here I'm going to go 0.5 plus 0.3790. I'm adding in both cases because both cases have a C-score that is positive. So let's see, 0.5 plus 0.1293. That gives me 0.6293. This is going to give me 0.8790. Minus, because I'm going to start from the big one, minus 0.6293. That gives me 0.2497. That's simple.